So unsupervised learning. As I said, it discovers hidden structure in unlabeled data. So clustering and anomaly detection allow you to have business cases like the following two examples. This one is for clustering. You can segment customers by their shopping behavior. So, for example, if you are Nike, depending on how you think it should be called, you might want to segment your customer base in order to personalize communications and decide, instead of spamming them for all the offers that we have for all of our portfolio, we're just going to send them the communications that are relevant to their tastes. So in here, you don't have a prediction variable. You only have a set of descriptive variables, like, for example, how often do they purchase? What is their average basket size, which is how much is their typical purchase in the Nike website? And what are their preferred products? If you apply this kind of data set to a clustering model, then the result will be groups that are clustered, which you might find out underlying hidden structure in that data. So you might decide that when you look at the clusters, some group of people are bargain hunters. They only buy things that are on sale. Like those people who, I might be one of them, might only enter the Nike website if they are attracted by some offer. And then there's loyal premium buyers. This would be like the people who collect all the sneakers, and anytime that something that is really premium will buy it. And seasonal shoppers who buy depending on the occasion. And then example 2, to flag unusual credit card transactions. This is very typical for anomaly detection. You don't have a prediction variable, but you have a set of data with descriptive variables, like what is the amount of the transaction, what is the kind of merchant where that transaction is going on, at what time of day is it happening, and at what purchase location, especially if you're in a different country. And when you look at most of the transactions, you might decide that if one transaction looks very different from the typical one, then you will raise a flag and say that you should check for fraud before approving the transaction, which causes, of course, customer losses and their frustration. Even in here, the model might be wrong, because anyone who travels knows that sometimes your credit card doesn't pass, and it's frustrating because it's that your bank is flagging you for an unusual transaction. Well, this is a case of a false positive, which is part of measuring models' performance, which we will look at in the next presentation. Here's an example of how clustering looks. This is an application of a very popular algorithm called k-means clustering, where you just have a set of data like this, which doesn't have labels of any kind. You just have some variable that describes it. And then you apply k-means, and it makes groups based on, let's say, it calls thresholds that more or less separate the points into similar ones. So all the red ones here are in a cluster because they are like in the bottom right side of this picture. But this is a very simple example. Here's a k-means algorithm where you have 4 clusters instead of 3, and where someone has drawn some ovals on top of them to make it clear. This could be the Nike situation. And in here, you might have in the x-axis some variable that represents their purchase behavior. And then you would need like a marketing team to look at this with the data science team and say like, oh yeah, these people here in this cluster, these are the ones who always buy the expensive stuff. So let's call this cluster the premium buyers, for example. It's used for this kind of task in marketing roles.